Hello, everyone. My name is Megan Carter. I'm the Community Director of ESIP, and I'm here to welcome you to the Earth Science Information Partners Putting Data to Work webinar series. This webinar series follows ESIP's 2020 year theme of putting data to work, building public-private partnerships to increase resilience and enhance the socioeconomic value of data. This webinar series has been going on throughout 2020, and it has moved beyond data discovery to explore how the Earth science community is putting data to work, using and reusing data in new and creative applications, creating derived products, and showcasing examples of data integration in order to increase resilience and to enhance the socioeconomic value of data. In addition, the series is also highlighting how public-private partnerships help to increase the value of earth science research to other economic sectors. I'm very excited to welcome Dave Jones here today. I'll share just a couple of quick slides about ESIP for those who may not be as familiar with it. ESIP's vision is to be a leader in promoting the collection, stewardship, use, and reuse of earth science data and information and knowledge that is responsive to societal needs. And for more than 20 years, ESIP has helped members of the earth science data community to find each other across traditional boundaries, to leverage each other's expertise, and to work together on common data challenges and opportunities. ESIP fosters rich collaborative experiences, including numerous community-driven virtual collaborations that I'll tell you about in a moment, through the ESIP Lab, which supports the development of innovative applied earth science technologies, and through 2 annual conferences. And you can see here that our next meeting will be in January online. The theme is Leading Innovation in Earth Science Data Frontiers. Registration is now open. We will feature more than 30 community-contributed breakout sessions. We're also building a great lineup of plenary speakers and numerous networking opportunities. So I encourage you to check that out and register. So much of the virtual collaboration that happens in between these 2 annual conferences happens through approximately 30 themed collaboration areas. And actually this list is out of date because we just had a couple of new ones started. These are groups of people that convene virtually regularly, typically monthly or sometimes twice a month, around an earth science data related challenge or opportunity. These are proposed by our partners. They spin up and spin down when their goals have been accomplished. You can see when these groups are meeting on the ESIP telecon calendar. There's no need to RSVP. We want folks to hop on and to share what their challenges or opportunities are and to see if it's a good fit for them. So no need to RSVP, like I said. So with that introduction to ESIP, I would like to introduce you to our speaker today, Dave Jones. Dave, I will pass the screen share to you momentarily. Dave is a 35-year veteran of the weather industry. He worked as an on-air meteorologist for many years. Ever the innovator, Dave developed the first television weather website in the nation in 1995. In 2001, Dave then founded StormCenter Communications, Inc., and spent many years funding research that led to an exclusive technology developed under the federal government's Small Business Innovation Research Program. This tool enables the sharing of trusted data across any platform in real time, improving situational awareness and decision-making across multiple sectors, agencies, and organizations. Dave is a past president of ESIP, and along with Karen Moe, he co-chairs the ESIP Disaster Lifecycle Cluster, which you saw on the last slide. Dave has recently helped to evolve the operational readiness levels, along with that group, for trusted data to drive decision-making. And these operational readiness levels are gaining popularity and of interest to many agencies who are looking to build trust for rapid decision-making that save lives and property. Dave and his StormCenter team have received numerous awards. To name just a few, StormCenter was awarded the Tibbetts Award by the Small Business Administration and was selected as the most recent recipient of the ESIP Partner of the Year Award. Dave was also awarded the Falkenberg Award in 2006. This is an award given by AGU and ESIP that honors early to mid-career scientists who have contributed to the quality of life, economic opportunities, and stewardship of the planet through the use of earth science information, and to the public awareness of the importance of understanding our planet. He's also a fellow of the American Meteorological Society. So, as you can tell by my long introduction, we are very excited and very delighted to have Dave here today to talk about some of his work. A quick note that if any of you have questions as Dave is giving his presentation, please type them into the chat box and we will address them as time allows once Dave finishes. So passing presenter to you, Dave, and go ahead whenever you're ready.
Oh, great. And thanks, Megan, so much. Let me just find the PowerPoint slideshow here to share, and just confirming that you can see it okay?
Yes, it looks great.
Okay, great. Well, thanks, Megan. I really appreciate that introduction, and it's great to be speaking in the ESIP webinar series, Putting Data to Work. That's what we've been working on for a very long time, and our relationship with ESIP has been great ever since the founding of ESIP in 1997, and I'm really happy to still be involved in ESIP as the co-chair, like you said, of the Disaster Lifecycle Cluster. So my talk today is about rapid scaling of sensitive information sharing in support of two recent contracts that we've received from NOAA. One is from the National Weather Service's National Water Center down in Tuscaloosa, Alabama, and the other one is with NOAA's Hurricane Research Division. And I'll talk about each one of those here in just a minute. But I did want to give a little shout out to Ellen McCrae, who's the Regional Climate Services Director for the Eastern Region at NOAA. I think pre-COVID, I think the last meeting that I attended was at the National Center for Weather and Climate Prediction in College Park, Maryland, back in February. And she stood up and gave a talk about services and how they're evolving within NOAA. And she really struck me with this little quote down the bottom here, that collaboration and cooperation are essential to service delivery. So if you're in any business or any activity and you're delivering a service, you really have to know your customer, you have to know what they want, you have to know that user, and sometimes delivering them the best technology isn't the right way to go. It's delivering a capability that they can use easily and understand that that data that they're working with. So essentially, you know, why am I presenting here today? Because the sharing of trusted data and knowledge is critical. I mean, we have more data available to us today than at any other time. That's the good news. That's the great news. The bad news is we have more data available to us at any other time than any other time. So it really drives the need for things like data analytics, trusted data sharing, collaborative environments. So people who are making these decisions get the right data at the right time for as long as they need it. And so essentially, I sort of speak for myself, but this may be relevant to you and your thoughts as well, that things, you know, just seem to be coming at us faster than ever before, whether they're environment related, whether they're weather related with severe storms, the number of hurricanes we've had this season, you know, all sorts of things, from, you know, politics to science. Things are just coming at us fast and furious. And so decision makers, we have the need to connect experts at a moment's notice. You know, this is developing. Who can I connect to? How can I receive information from them in a way in which I can process it and then make decisions? And the federal government and states are looking to put more of their data to work, serving citizens. There's a lot of data collection activities going on in the federal government. There's a lot of computing power going on, a lot of forecast models being run, and a lot of situational awareness that has to be improved throughout the federal government, and they need to share that data out. So decision makers, while they have all this data available, they really do need to trust that data to improve the confidence that they have in making certain decisions. Nobody's going to get data and information that's going to make a decision maker 100% confident with every single decision they make in a developing crisis. But certainly they want to use the data that they trust the most so their confidence can be high. So I wanted to just spout out some hurricane facts for the 2020 season. You know, back in August, where we hadn't even reached the peak of the hurricane season, the director of the Hurricane Center, Dr. Louis Usolini, says we have already been experiencing a record-breaking hurricane season. It's because of the number of storms that have developed, how early they developed with relationship to their names, and all that sort of stuff. The forecast for NOAA's hurricane season this year, expectation of up to 25 storms is the highest number NOAA has ever predicted. It's estimated there would be just 21 named storms in 2005 when we broke a record. That was the most active year in history to date. Well, so far we've had 29 named storms and another one likely on the way. We have one in the Caribbean that the Hurricane Center has given an 80% chance of development within the next 48 hours. So all eyes again are focusing on the Caribbean as Eta starts to emerge from the Florida coastline. Louisiana has been hit by 5 named storms. 5 named storms. Eta that we just experienced in Florida has now been a named storm for 9.5 days. So that's now tied with Gordon in 1994 for the longest lived Atlantic named storm, forming in November in the satellite era. So that's since 1966. And Eta was named on November 1st. That comes from Phil Klotzbach, friend and colleague out of Colorado State University. And Eta is the strongest Greek alphabet storm on record, winds of 150 miles per hour prior to its landfall in Nicaragua. So we're seeing a lot of late season storms, and these storms are getting quite strong. Well, Florida, they've avoided landfalls this season until Eta, which made landfall twice as a tropical storm, once in Key West and once this morning just north of the Tampa Bay area, as it continues to impact Jacksonville and the Florida Peninsula, soon to emerge off the Atlantic coastline. So just a quick look at the Atlantic hurricane season so far. I mean, out in 2020, we have observed 29 named storms. The average is 11.4 named storms. So we're 254% above that average. And that ranks 2020 as the #1 most active season in the satellite era. So congratulations, everybody. 2020 yet gets another hashtag for weird and strange things to be happening. These are all the rest of the statistics. You can go back and look at that, but accumulated cyclone energy index, 159. The average is 101, so we're 157% above that. What's interesting to see, though, is the average accumulated cyclone energy index is really active in October and November. So that's really has sent us over the edge of this cyclone energy index average. So it's pretty amazing. What that tells you is more active hurricanes, more energy in later years. That really relates a lot to the sea surface temperatures that are well above average and continue to be well above average. And just take a look. This is where all the tropical systems have made landfall so far this season. So we've had 13 landfalls, and we have Eta there just north of Tampa. That's the newest one, which made landfall around 4:10 this morning, just north of Tampa, with some pretty significant storm surge in the Tampa Bay area, 3 to 5 feet in some locations, which has caused some flooding and at least one death in Bradenton, Florida, when the water came over the seawall, went into a home, and electrocuted a homeowner, which is very, very tragic. So even in Louisiana, what they have seen some serious damage with Hurricane Laura, which was a Category 4 storm that made landfall. These are aerial pictures of the damage that the storm surge brought in. It was a 12 to 18 foot storm surge. And you can see some empty pads there of mobile homes just ripped from their pads, and just terrible area hit. Cameron, I'm not sure how much they're really going to be able to recover after this storm, because Hurricane Delta came on Cameron's heels 6 weeks later and dealt them another blow with another significant storm surge. And I'm sure you saw impacting Lake Charles and all that stuff. If you see a satellite picture or a high-res image from Lake Charles, you'll see more blue tarp covered roofs than you will regular roofs that haven't been damaged. So we've seen a lot of impacts on the coast from here. And when Eta made landfall in Nicaragua, a Category 4, almost a Category 5 storm, with many, many people killed and serious flooding there. So To get back to the reason why, you know, all these things are happening, what do we have available that we can put people on the same map at the same time to look at the same data and share it across any platform? And that's our technology, GeoCollaborate, which I'm here to talk about today, which connects people on disparate devices just through a web connection, placing everyone in a synchronized fashion on their maps in real time, so data can be accessed and shared from trusted sources. So never before has a technology like this existed. And the nice thing is that there's no extra hardware footprint needed in anybody's office. It's connecting to a URL and turning GeoCollaborate on. And hopefully we have time at the end here where I can do some real-time demonstration with you while you're connected. And so this is essentially how web briefings are done today with either PowerPoint or web browsers and screen sharing technologies. So we're using a GoToMeeting right now or a GoToWebinar, and you can see my screen. Well, GeoCollaborate is a step beyond that, where we actually share the data into your device or into your computer. But today, the way that webinars are done, you might have this in your own web you know, browsers where you have 50 tabs open and you're sharing your screen and you go between these different sites. You're changing projections of your maps, you're showing different things. And, you know, study after study after study has shown that the brain, the human brain, it's hard to consume information when you keep changing the source of that information, like changing your web map projections, going from text to all sorts of things. And so if you can keep certain things consistent, like the projection of the map and the zoom level of the map, that takes away a lot of the thought process from the human brain, so they can focus on the data and the information that's being provided. So you can think of GeoCollaborate as accessing all these different websites or portals or hubs and pulling out the relevant data that's needed to display on a map. So you might have all these complex systems out there doing this stuff, could have people running data analytics and automated intelligence algorithms. But what GeoCollaborate does is takes that answer, that data source, and displays it on a map so we can display multiple sources on a single map that's collaborative. So the people on the other end that are collaborating don't have to worry about where this data came from. If you're presenting it and you're a trusted subject matter expert, then your collaborators will trust your information that you're delivering. So in this particular example, in the blue dots are COVID counts for the states. Red states declared states of emergency. This is not current. And you might see real-time earthquake detections from the USGS, along with weather watches, warnings, and advisories from the National Weather Service. And these little green dots in Pennsylvania, where my cursor is moving, were open rest stops based on COVID-19. So truckers knew where they could stop in Pennsylvania. So it's all about trusted data sharing across these platforms. From a user interface standpoint, this is how GeoCollaborate looks. In the upper left-hand side, you have the leader where they take control and they have credentials. They can access data sets from any location and then share them out in real time to any follower who is just joining through a web link, turning GeoCollaborate on. And as soon as they turn GeoCollaborate on, they catch up and get all the data sets along with the movement of the map in real time. Down the bottom is a collaborative dashboard that displays any data layer that the leader activates, and it puts more of the turning on and turning off of those layers in the hands of the user. So the one that's in a emergency operations center, or the one that's in a transportation operations center, or a citizen in public. If they go and click on a particular data set, that will turn on, and then they can start to click on that data to find out what it means. So we really think that this is an awesome opportunity to expand the public's access to geospatial data in a way in which they don't really have to think a lot about it. We're still evolving the interface and the way the public can make access to it, but we're really pleased with the progress that we've been making so far. And so some of the contracts that we already have that we've been working on for a number of years with NOAA in the JPSS program include two initiatives that we've been funded under. One is called Fire and Smoke, and the other one is called River, Ice, and Flooding, where we're increasing the use and understanding of NOAA satellite data for decision makers. So you can think of StormCenter as playing in an area where the rubber meets the road, where decision makers want to use science data and earth science data for decision making, but they have no idea where to find it, what it means, how to interpret it, and how to use it and integrate it into their decision making processes. That's where StormCenter Communications and our team comes in and really plays a critical role in putting this earth science data to work. On the left-hand side, this is an example of a product in GeoCollaborate. The colorful visualization you see is smoke. That's the high-resolution rapid refresh model from NOAA, which is predicting a smoke dispersion near the ground because of the western wildfires. And the dots that you see are not locations of the fires. That's a data set from another federal agency, the EPA, with their air quality index measurements. So they have sensors on the ground. This is from their Air Now program. So you can actually click on those dots and you can see what the PM 2.5 concentrations are and PM10, other things that they measure. So just with these two data sets and using GeoCollaborate, we can have a collaborative session where we're validating and verifying the HER smoke model forecast and the actual measurements that are occurring on the ground from the EPA sensors. On the right-hand side is an application of JPSS data in the flooding area. So anywhere you see an orange and red and yellow, that's where water has been detected from the VIIRS sensor on board NOAA 20 or SNPP, the SUMI NPP satellite. It's all part of the JPSS system, is detecting, and then through algorithms running to say, hey, water shouldn't be here, so this is flooding. And there are lots of activities going on to validate and verify this. FEMA has adopted it. They have it in their operational decision-making arsenal. And then this purple area is a geospatial message that can be issued through GeoCollaborate, bringing attention to other users of GeoCollaborate, whether they're using the dashboard, just connecting through the URL, or they're a follower, where we can issue geospatial messages specifically to people. Here's an example of the JPSS River Ice and Flooding Initiative where we put GeoCollaborate to work to identify an ice jam in Alberta, Canada. This was just this past spring. The green dot is where a camera is located, and the red is ice. And there's flooding going on. So there was an ice jam that's backing up a lot of this water downtown in Alberta at Fort McMurray, and you can see the picture on the right. Certainly the ice chunks you can see, and also that the city has been flooded. And Fort McMurray experienced their worst flooding in 100 years, more than 100 years, according to the local government officials there. So when I talk about these data layers coming in, it's simply just as you would imagine. These layers could be separate services that are being produced by trusted data providers. So certainly NOAA is a trusted data provider. The National Weather Service has their geospatial data engines at work, and they're increasing the number of data sets that they produce. It could be NOAA's NowCoast system, which they're very qualified geospatial experts, and those services are improving day after day. Could be from FEMA, EPA. NASA's disasters program is standing up their disaster portal, which is going to be making more and more data possible to grab as a service and integrate into things like GeoCollaborate and other GIS systems. And you might see in the middle here, operational readiness levels. We've worked very hard in the disaster lifecycle cluster to evolve operational readiness levels so decision makers can look at the ORL level and trust that data. It's not a trust level for all their decision-making capability, but it's a trust level for that particular data set and its timeliness and trustworthiness, so we can lower the confidence or increase the confidence, if you will, we can increase the confidence of a decision maker when they see higher ORL levels. And it's great. We talk about this a lot in our disaster lifecycle cluster telecons. I hope you can join us. It's on the first Thursday of every month at 4 p.m. Eastern time. The All Hazards Consortium is a group that we work with very consistently and have been for years. They have a membership of over 45,000 members, and they've put together this one pager, this front and back here, that talks about how disasters require faster decisions. But can you trust that data? So they talk about benefits of the operational readiness level, how the ORL numbers are reflected in the GeoCollaborate dashboard, because the All Hazards Consortium has adopted the GeoCollaborate technology as their data sharing platform of choice. So that's been happening over the last couple of years, and it's really been used by utility crews who are responding to power restoration activities after landfalling storms and ice storms and things like that. If you probably have seen them in your neighborhood at times, where you might see a power crew from Mississippi in Alabama restoring power, or from Michigan in Florida restoring power. That's all called mutual assistance, and those utilities utilize GeoCollaborate and other technologies for improving the routing of their crews to the most efficient route. So it's all about really putting complex data to work efficiently. But not only doing that, but doing it in an easy to use and easy to understand way. And here's the critical thing, and where we focus on a lot. And that's making this science data matter to people who would otherwise not care. So people that look at a satellite image or look at something that looks like it has some science in it and quickly turn away, once they understand what that information means, boy, it can change their entire outlook and approach to not only themselves and their decision making for their families, but if they work in a corporation, really improving efficiencies of the operations within their corporation to put this data to work. And much of it is open data. It's free and open. So the way in which briefings were done, and I mentioned this before, but pre-COVID, this is a Weather Service example of an emergency response specialist being deployed and being in a emergency operations center. And on the right-hand side, remote briefings using screen sharing. But what we don't have in both of these pictures are people being close to each other and really collaborating in person. So there is not only a directive to work from home, but there's a need to place people on the same map at the same time so they're looking at the same data. And that's what GeoCollaborate does. So you could have somebody from the Weather Service leading a collaboration session where FEMA has joined, the field has joined, emergency operations centers from states have joined, an incident commander or police chief or utilities, and they're all getting the briefing and receiving the data in real time. So what we've coined the term is a collaborative common operating picture, if you will, where everyone is receiving the data and they're able to query it in real time. So they're able to really take this to the next level and put data to use, especially when they haven't even, may not even know that that data has been made available. So our work over the last couple of months has taken a great turn where we're working now with NOAA's National Water Center on the left-hand side here, and also NOAA's Hurricane Research Division. So both of these agencies are really seeking to connect more scientists and decision makers in real time, so they can share the data across their platforms in groups that they look to provide either impact-based decision support services to, or share real-time science data, no matter what platform that's being used. So the goals of the National Water Center, this is just a partial list, but the first one is to share information and knowledge effortlessly and effectively, to have a robust opportunity to connect with user communities, such as what the All Hazards Consortium can bring to the table. We have the opportunity to put National Water Center products in front of utility responders so they can give us feedback for whether or not they think those products and services are valuable or how they might be able to be modified to be even more effective. They want to deploy it in operational and training environments and to put geointelligence data to work. So all of these developments are very exciting for the National Water Center. And this is just a look here within GeoCollaborate of the National Water Model. It almost looks like they're veins going through your body, supplying the much needed nutrients and oxygen. But these are the water and river sheds and streams in the US that really feed communities. And some of them are lifelines for delivery of commerce and products like the Mississippi River. And what you're looking at here is actually a national water model anomaly depiction. This was, I took the screen grab just a couple days ago before Ada was approaching the Tampa area. But you can see when rain falls, I have the real-time radar data on top of this, the flow of the rivers change. And if they get anomalously large or small, they'll change colors. And this is something that is just a phenomenal product. The National Water Center has great geospatial expertise, probably the best in the Weather Service with the number of people that they have there for processing this data and making it into services and all that stuff. There are others certainly around the Weather Service that are doing a fantastic job. We need to see more of this. We need to see more geospatial data offered by NOAA centers and NOAA line offices that can be pulled into GIS systems and immediately used for decision making. These are huge benefits that the American people will realize. So the National Water Model is a high resolution model to identify where inundation might impact lives, property, and businesses, commerce. The Weather Service is really building that capacity to connect with decision makers very quickly as they get up to speed with GeoCollaborate, and we do more training and get sort of embedded into some of their operations. We'll be able to really suggest ways in which they can use GeoCollaborate to stand up very, very quickly to collaborate with federal agencies, states, other core partners. They have really been slammed hard with all these landfalling storms because, you know, when a hurricane makes landfall, it's not just a wind problem and a storm surge problem. It moves inland and creates a lot of flooding and a lot of dire situations that the National Water Center has to be on top of 24/7. So we are seeing a little bit of extended time to get GeoCollaborate integrated into some of their operations because they're out saving lives. And as soon as that backs off a little bit, we'll really be excited to engage with them. We're connecting with additional users to increase the awareness of NWC products like the utilities, food, fuel, transportation, and communication sectors. For the the NOAA Hurricane Research Division, you probably have seen these guys around. They're the ones that fly into hurricanes. They dedicate their lives and risk their lives to take measurements. This one is Hurricane Dorian a couple years ago, where look at that eye wall, just incredible. Winds of 175 miles per hour. And that P3 airplane flies right through the eye, penetrating the eye wall numerous times. And look at that down there. Those are 50-foot waves that are being generated by those strong winds. That plane's flying at 5,000 to 7,000 feet. And when you can see those kind of white caps out there, they are huge swells. So hats off to the hurricane hunters and NOAA's Hurricane Research Division. Boy, they are really doing yeoman's work in collecting data, particularly this year. I don't think they've had a chance to breathe, to maybe to get home, wash their clothes, and get back on another hurricane flight. So this is kind of how the hurricane surveillance works, where you have the Gulf Stream, the G4, which is flying at a high altitude around the environment of a hurricane, taking measurements and doing dropsondes to really feed numerical weather prediction models. And then at lower elevation, the P3s come in and fly these missions where they're penetrating the eye of a developing storm, feeding back data in real time. So here's the thing that they would like to improve. These planes cannot share data with each other. They can't share graphical commands and things like that. They want to be on the same map at the same time, so they're looking at the same data. And more importantly, data that's being collected and being sent back to NOAA can be integrated into GeoCollaborate and you have more meteorologists on the ground looking at this data, and then perhaps sending back a coordinate or two where they'd like the plane to fly through the storm because they're seeing some rapid intensification or things like that. So GeoCollaborate is going to improve the science and improve situational awareness and decision making, where we could perhaps even bring in more meteorologists at the Hurricane Research Division looking at that same data, perhaps even the Hurricane Center, hurricane specialists looking at that data, bringing in GOES data, bringing in radar data, bringing in data from the airplanes and other model information, all on one geospatial display, and then asking questions. So if the Hurricane Center says, hey, we have a question about this, then if the P3 is still in there, they might be able to re-vector a little bit and fly through an area of interest. So we're very, very excited about working with the Hurricane Research Division. Their project, the Hurricane Forecast Improvement Program, continues to get funding from Congress, which is awesome. And as you know, we're working on storm number 30 this season. And boy, this program really needs to continue to be supported. This is how it works graphically. So you might have data being collected from one of the P3s, NOAA 42, and sharing it to the G4 and another P3, and maybe to the Air Force. The Air Force is equipping their C-130s with internet connectivity. And then if any other organization like Southern Region Headquarters, the Hurricane Center, Environmental Prediction Center, WFOs, or the Hurricane Research Division connect late, they will all catch up and be on that same visualization platform as well. Tracking the plane in real time, and improving the efficiency of this data sharing. And since this data is produced in a web-friendly format, we're maximizing the use and minimizing bandwidth. So that's really critical when you're up there and flying. You don't have unlimited bandwidth. Here's an example of what we just did in Hurricane Laura before it made landfall in Louisiana as that Category 4. This is GeoCollaborate screen grab, where the leader down at HRD was drawing a flight pattern that they wanted to update for the airplane. The followers were following in real time, and this is the actual flight plan that was generated from that GeoCollaborate collaboration. So within a couple days of training, they were putting GeoCollaborate to work immediately, which is really very encouraging. And as soon as they can put their feet back on the ground, we'll be working a lot in the off season to improve their use. So here's what we're really focusing on with the use of GeoCollaborate. That's improving the trusted data delivery into the hands of scientists, decision makers, and the public. That can be extended into the education area, so graduate schools, universities, even undergraduate and K through 12, maybe the high school level, can start to learn how to share data and work collaboratively with other students, maybe down the hallway or in the same district, school district, or in other states, or maybe even other countries. So we can really build up the capacity of our kids to learn how to work collaboratively and not just on their own. It can be applied to training, exercises, cross-agency and cross-sector, even cross-private sector organizations can share data securely for a limited amount of time, and just putting their data to work, helping. Where might that work? Well, perhaps a utility and a communications company share the same utility lines. Sharing information could be very beneficial and save a lot of money and accelerate restoration of services. So when data is made available as a service, bandwidth is conserved. Collaborative decision making enables new data to be shared onto all web maps. So if you're using your tablet, your phone, or whatever, we can bring more science data into this environment. And the querying of that shared data enables independent analysis that can be conducted concurrent with the briefings. So if someone is briefing you on a larger area, you can start inquiring on data sets in your area while that briefing is going on. So you're actually able to interact with that data. All data or some of the data can be shared in a public-facing dashboard. So we can start to incorporate the public and get more transparency going on with what's happening. We did this in California wildfires with some Wildfires we were supporting with the California Civil Air Patrol and the California National Guard. We were really able to put some of that information to work very quickly. Operational readiness levels from the ESIP Federation and the All Hazards Consortium really can fuel this concept of 30-second decision making, which utilities are really pulling on hard to make sure that they are connected and can trust this data. And GeoCollaborate enables the rapid scaling of critical information sharing, so anybody can connect on any device at any time. You don't have to have a license beforehand or whatever. You just have a URL and click to start doing that data and information sharing. And so we're working on all sorts of use cases like mutual assistance, wildfires, government and private sector collaboration, railroad disasters, improving hurricane forecasting, things like that. We're constantly thinking of use cases to put together harmful algal blooms, how we can use satellite data from NASA and NOAA to really improve the monitoring and development of harmful algal blooms, where they might be moving, so we can create some sort of public facing interface to let people know, don't go swimming here today, it might be better tomorrow, here's some official word, things like that. Really very exciting. And I just wanted to show this ESIP winter meeting summary. We put this together back in February, but in the winter meeting, pre-COVID, when we could really get together and do face-to-face discussions, we engaged the All Hazards Consortium, we engaged utilities, we talked about private sector data sharing, ORLs, and what are the pathway forward. All of this is being discussed in the Disaster Lifecycle Cluster, which is part of the ESIP Federation. And so again, every Thursday, first Thursday of every month at 4 o'clock Eastern, please come in and join those conversations so we can talk about it. I mean, here's the executive director of the All Hazards Consortium, Tom Moran. He says the sharing of trusted information drives decision making and shortens response time. Data can support community lifelines efficiently when it has an associated ORL number. So that's really quite exciting. And so what I'm going to do here is I'm going to share a URL. I think we still have some time. We do. We have a few minutes. So those of you that are on and participating, what I'd like you to do is open up a browser, a new tab in your browser. Use Chrome, Firefox, Safari. They're the best ones to use. I put in this presentation too a link to the California wildfire use case. That's just a YouTube link you can click on and go to. But what I'm going to do is I'm going to go to my browser and pull up GeoCollaborate. And so what I'm going to do here is bring that up, and I want you to go to that dave.geocollaborate.com. Make sure you put in. I think I paused my screen sharing, but it did it automatically. But that's okay. I'm gonna turn it back on and just share my screen so you can see me working as a leader. So make sure you do HTTPS because it's a secure connection. Then when you come to the landing page, click follower. And when you click follower, a map will load up. And once that map loads up, I want you to turn on GeoCollaborate in the upper left-hand corner. So Megan just shared in the chat the link that you can click on to connect. So once that map loads up, turn GeoCollaborate on, and then your map will match my map. So what you should see is the previous track and wind field of Tropical Storm and Hurricane Eta, its current position over Jacksonville, and the National Hurricane Center forecast that's taking it right off the coast of the Carolinas. They will be impacted because the storm has a larger wind field. You see the flood watches, warnings, and advisories that have been issued in Virginia and North Carolina, and you see the rivers that are under flood warning right now. So as I move my map around, your map will follow me in real time. And so what I'm going to do is I'm going to go and I'm going to turn on a data set of observations. I'm going to turn on the buoys and observations from the National Weather Service around the marine environment. So here's an example. I'm going to zoom into the path of the storm. You see some buoys there. You can click on that buoy data that I just delivered to you. So if you want to see an observation, you can click on it and that real-time observation will show up. And that's right now, the latest observation. So here we have a data set that you don't know about, and one in which you have now been able to query. And now I'm going to draw a freehand polygon here across the Carolinas. And what the system is doing is it's now going off in real time to the Socioeconomic Data Access Center, NASA's CDAC at Columbia University, run by Bob Chen. And it's just doing a query for the population that lives in that area. And sometimes it comes back quicker, sometimes it comes back, takes a little bit of time to come back. But what eventually shows up is the population in that area that I drew. And I'll let that roll on a little bit, but I'll zoom out and display a satellite image as well. And so I'm going to display, a satellite image, GOES 16 satellite image of the full disk image from NOAA in a tiled format, so you can now see the visible satellite image. If I turn off the tropical advisories from the Hurricane Center, so you can see what's going on with the satellite image, now we have the spin of the storm and you can see what's going on. It's just moving outside of Jacksonville, emerging over the ocean. And this is a lot of low clouds in upper Georgia and Alabama, convective clouds and flooding going on across the Carolinas. So that's what's going on in a real-time collaborative environment. So we're really pleased with the collaborative capability that's happening. If I zoom out, you'll zoom out, and the rest of the satellite data will display along with the real-time weather of the buoys. If I turn on sea surface temperature data, we can see the sea surface temperature data come in underneath of the clouds, so I can fade out the clouds a little bit and you can see the sea surface temperatures underneath. And then if we turn back on the buoy data, you can go in and see what these sea surface temperatures are in real time. So some of these buoys aren't working because they just need some maintenance, but you can see the water temperature 78.8 degrees right here with that color underneath of it. So I'm going to end my my presentation here. Hopefully we can have some questions. I haven't been able to see the comments, but we can start a little discussion. And I just want to thank you, Megan, and Karen with the ESIP Disaster Lifecycle Cluster. Karen's been really active and participating in the air quality cluster and agriculture and climate cluster and all that stuff. So ESIP is making a big difference in putting data to work, and we're really pleased. And I'm also very honored to have been the partner of the year for ESIP. It was really touching to be given that award in January, and I hope to live up to continuing the partnership capability and outreach. So we can put GeoCollaborate to work and put much more NASA data to work. So let's see, Megan, I'm not sure what you'd like to do from here, but
what I would like to do is thank you for this presentation and say, you know, we are so fortunate to have you in this community and to see this work. It's very, very impressive. We're grateful for the leadership you've played in ESIP and the work that you and Karen do with the cluster. So with that, I'd like to turn it to others to see if there are any questions. I do see that there's one in the chat box, so I might start with that, but if others have questions, please pop them into the chat or I'll invite you to unmute in a moment. Dave, can you talk about what outreach has been done to local governments on ORLs and using these types of tools for decision making?
Sure. So local governments are starting to notice GeoCollaborate as we work with the All Hazards Consortium. State emergency operations centers and local areas. For example, we're working now with the state of Florida to improve their observations of harmful algal blooms. And so as we make progress within that particular project, we're hoping to create a public facing dashboard and a dashboard that local officials, because when you're talking about harmful algal blooms, you're talking about sort of sometimes local developments of these blooms that are toxic, right? You have fish kills, can cause respiratory problems in humans or other types of infections. And so that's an area where we think there is a room for rapid growth, because these local governments, sometimes they don't have the funds to really make big investments in a lot of technology, where we can really take their data and put it to work. So the ORLs seem to be very beneficial with the decision makers, because the more they understand about how ORLs are put together, then the more they can say, wow, we want to be a part of that. And we want to put our data through the ORL process so we know how it should be ranked. I mean, in ORLs, there, we ask questions in the whole process of, is there a backup servers? Is it HTTPS? Is it a secure connection? Is there somebody to call if you have a question about the data? So there's a lot of really good information in there, and when the ORL rankings really catch on in local governments and others, I think it's going to be a very widespread capability of trusting this data. And so I think it's going to be critical to driving decision making. I mean, you have to have trusted data to drive these decision making efforts. The challenge that everybody has is that there's so much data out there, they're overwhelmed. And so we're really hoping that through ESIP and through the All Hazards Consortium and through our federal government contracts, we can really spread the word about this, not just GeoCollaborate as a technology, but that it can open up the doors to accessing more data.
So Dave, the chat box is blowing up with questions for you. We only have about 4 minutes before I need to wrap up. So could you comment on the use of GeoCollaborate on mobile devices?
Yes, so it works on any mobile device. If you connect through your web browser on your phone or tablet and turn GeoCollaborate on, you will be able to follow the leader. As we mature the technology, we'll be making it even more friendly for those mobile devices. We haven't created separate apps because it's just a URL you can click on. So we've had many people that have been in the field, whether it's through wildfires or others, that have been able to connect and really follow along with the leader, so they can see what's going on. I did see the message from Bob Chen, so Bob, I'll try the population query, just see what's happening. It might be my cache sometimes, so I'll just do that query right there. Okay.
Great. Can you Bill Tang is wondering if you can talk about incorporating social media data, though they lack ORLs.
Yes. So we worked and have had meetings with a number of social media sort of aggregators and analyzers, if you will, that do that kind of stuff with their job, and they take a look at social media feeds and can break them down into services that we can consume within GeoCollaborate. So yes, we can turn on and off social media feeds. They might be extra subscription services that you have to connect to. So we're working on potential partnerships with these companies. So if you, for example, wanted to get a Twitter feed of all flooding reports, you would have a subscription service that you'd have to pay. So you would pay StormCenter and we would pay them. and you could just turn that feed on and off. So we're really excited about that kind of development too.
Wonderful. Your disasters co-chair, Karen, is asking, is the National Weather Service making any of the GeoCollaborate services directly available to the public to help explain weather events?
Yes, exactly. So let me look down. The Weather Service is looking to do a couple of things, and we're really pleased to be working with the All Hazards, or the Tuscaloosa group, the National Water Center, because they are taking a leadership role in putting geospatial data to work. And so they're thinking of all sorts of ways to sort of blow the doors off of GeoCollaborate, if you will, so they can put it to work not only with other federal agencies, but also making GeoCollaborate available in a web presence. So that's they have someone at Weather Service headquarters, obviously, who's the program manager for their web capabilities. They've indicated some interest in learning more about how GeoCollaborate might be embedded into Weather Service websites, so the public can get access to more specific information easily. There are a lot of capabilities out there right now to access a lot of weather data, but the public is not usually as eager to click on a lot of things, and they don't really know what meteorological parameters mean. So the challenge really is putting products together that are very useful for the public to make decisions.
Thank you, Dave. We have one more question from Jack Settlemeyer. Is it too soon in your collaboration with the National Weather Center, National Hurricane Center, to see any NWC data in this view underneath these FFW polygons?
Oh yeah, no, so great. That's great. So here, if you're still seeing my screen, I think it's a little message to Bob Chen. I think my cache on my other browser was probably a little full, but I drew this population estimate, and you can see how fast that happened in this instance. This is All Hazards Consortium instance. And it pulled out the population from 2000, 2005, 10, 15, and then an estimate for 2020 with a demographic breakdown. This is actually, and I'll get to Jack's question in just a second, this is actually a amazing capability that opens the doors to all sorts of NASA data sets, particularly at CDAC, where we can do real-time queries of population data, extracting information that they're expert in producing. So this was a real-time query, came back, and now it's collaborative across the platforms, not the one I was demonstrating because I just used a different instance here. But for Jack's question, yes, we can bring in, matter of fact, I'll go back to my Dave instance and turn on, let's say, the stream flow anomalies. And so you can probably see in the screen share part, at least, and maybe where you're following, the stream flow anomalies as the flash flood warning polygons have been issued, and you can see a lot of purple. I believe that's higher than average and maybe flood conditions. So this is a great opportunity to bring in the national flood model or the national water model with their different parameters and overlay on the Weather Service polygons for watches and warnings. So this is hopefully this is what you were looking for, Jack. And yes, there's a way to do that. And what we'd like to do in the future is be able to make these flows clickable, so we can click on them and get actual flow information from these streams, and then dive even closer into high resolution imagery to see what roads might be inundated, so we can really save lives and property and direct utility trucks down the right roads, not the flooded ones.
Thank you very much, Dave, for addressing all of those rapid fire questions. It's been really exciting. I'm sure we could probably spend a few more hours looking at this. I want to thank you again for your presentation, and I want to thank all of our participants for your excellent questions. I'm sure Dave would love to hear from you if you have more questions to discuss. Maybe, Dave, you could pop your email address in the chat box. So I recognize we're after the top of the 1 o'clock Eastern time hour. I want to thank you all for attending and say that this concludes our 2020 webinar series focused on putting data to work. We'll be back in 2021 with a new series, likely beginning with a webinar just after the winter meeting featuring fast-paced highlights from it, so you can look forward to that. Until then, we hope to see you join us at the January ESIP meeting and in our regular collaboration area activities. You can also look out for the next ESIP Lab request for proposals, which should be out next week. To stay up to date on all things ESIP, we recommend you sign up for our Monday Update mailing list. You can find this at bit.ly/ESIP Monday Update. And finally, I'd like to note that this webinar was recorded and will be posted to YouTube if you'd like to look back at it or share it with anyone you know. Thanks, everyone.